Okay, so we can start. Good afternoon, everyone. My name is Ines, and it's good to have you all here. Welcome to R&D Sessions powered by EDP. We are the research center of EDP Group, and we work on European R&D projects looking at innovative solutions for decarbonization, smartification, and flexibility of the energy sector. And the aim of our sessions is to get together experts to discuss several topics regarding the future of energy. Please note that these webinars are recorded and the previous sessions are available on our website. You just need to read the QR codes on the next slides. Also, this session will be available in our website and YouTube channels in a couple of days. For today's webinar, we have 3 guest speakers with us that will share their insights with us. So I want to encourage you to use the Q&A chat to ask your questions to them. And at the end of the session, we will have a Q&A moment. With no further delays, welcome again to our event and wish you all a great session. But let me first introducing you our moderator, Samuele Matias. So Samuele is our R&D project manager at EDP, where he actively contributes to electric mobility projects. Prior to this, Samuele worked in the transportation sector, where his responsibilities included infrastructure monitoring and design. Samuele holds a PhD in transportation systems for the MIT Portugal program and a master's in civil engineering, both obtained from the Instituto Superior Técnico in Lisbon. Driven by a passion of innovation, Samuele's primary focus lies in the development of cutting-edge mobility systems that contribute to the ongoing decarbonization transition. So now, Samuele, the floor is yours. Thank you so much.
Yeah, well, thank you, Ines. And hi, everyone. Welcome to today's R&D session, powered by EDP. Our main topic for today is the future of electric mobility and the challenges that lie ahead. And we all have witnessed this incredible evolution in the EV sector. So I remembered when we held the mobility R&D session 2 years ago, and at that time we had about half of the number of EVs on the road compared to today. So right now, today, there are over 40 million EVs globally, with China leading this fast growth. And by next year, if this current trend continues, China, the world's largest car market, will also see more EVs sold than traditional vehicles. So that's something that we cannot ignore. But that's not just about light EVs. We are starting to see momentum in the electrification of non-conventional vehicles, which traditionally present more challenge than that light EV does. And globally, we now have more than 600,000 electric buses and more than 300,000 electric trucks. However, with this electrification, we must guarantee that our grids are prepared to handle this higher electricity demand. And the question is no longer if large-scale EV adoption is possible, but rather how we can ensure that our infrastructure is ready to support this surge in demand. If we look at this graph, by 2030, we're expecting over $500 billion in green investments globally. If you sum up everything until 2030, that's equivalent to the GDP of France by that time. So we need to manage these with smart charging, demand response, fleet management, and new charging technologies. So today you'll be hearing from experts who will share their insights on this. And for today, our agenda will start with grid planning, considering EVs, presented by Samuele Grillo. And afterwards, Christian will introduce a new charging technology. And we'll conclude with Alexandre Santos, who will showcase the new electric fleet of ferries at Transtejo, Soflusa. And let's begin with Samuele Grillo. Samuele has a law degree in electronics engineering and a PhD in power systems from the University of Geneva. He is currently an associate professor at Politecnico Milano and has contributed extensively to CGRE and IEEE working groups, focusing on grid performance and protection systems. His expertise in grid planning is essential to ensure that integration of EVs into our grids is both efficient and sustainable. Samuele will present a new project that exemplifies these concepts in action. And well, thank you, Samuele. The floor is yours.
Thank you so much, Samuele, for the introduction and most importantly for the invitation. So as you as you were mentioning, I will talk about this project, which is AHEAD, AI-informed holistic EVs integration approaches for distribution grids, which started on June the 1st this year. And the aim of this is to understand and to demonstrate how flexibility can play a role in distribution system planning. This is a very brief agenda in this 10 minutes. So an introduction on flexibility, then we will explore which is the impact of flexibility on planning, and then we'll draw some conclusions. Being the first to speak gives me the advantage of using this line, which is I asked to ChatGPT, okay, can you draw me a picture on flexibility? So let's make this this drill, everyone. Think about flexibility. And what ChatGPT prompted me was this image, the image of a lady doing his presumably yoga exercises in a very soft environment. And is this the picture you were crafting in your mind when thinking about flexibility? You see, it's a comfortable environment, nature, simplicity, and somewhat it relates to slowness, something we might appreciate in this time. But then I asked, okay, and apply this to power system, and the picture dramatically changed. And what we see here is quite the opposite of the picture before. So flexibility in power system is perceived as something which is complex, which is hard to achieve, and as we can see here, is based on decision support systems, and which in some way indicates the idea that cannot be attained naturally or naively. So it's not something that can be reached smoothly and without efforts. So we don't have to take the response of ChatGPT as something that cannot be modified or something that has to be taken for granted or verified. But I think that in many people would think in the same way. So flexibility is something that it's not related to a specific technical topic such as power system stability or power system inclusion of electric vehicles or inclusion of electric vehicles. So it's something that is related to more natural context and environment. So the impact of flexibility on power system can be considered at two levels. On the operation, so can flexibility be effectively provided, and to what extent? Many actors in power system, they do claim that they are able to provide flexibility, but is it true? Is it so? And are there some constraints that have to be considered during operation? The other aspect where flexibility can have an impact on is planning. So can flexibility play a role in planning? This is something that hasn't been really investigated too much in the research activities, as flexibility is usually considered something which pertains basically only to the operation level. And this project I'm talking about aims to fill this gap and basically demonstrate how flexibility can play a role also on the planning phase. So this is the outline of the project, of the partners of the project. I would ask you to join us on LinkedIn following this QR code, this link. So the flexibility can be accounted for when planning a power system. This is the main question that we are going to answer during our 4-year project. It's a project with 21 partners from 9 different countries. You can see they are here highlighted in red, and also with some associated partners coming from the same countries and also from the UK. These are all the partners, and I'm very happy to have EDP and Easelink as part of this project. Sorry for this cough. It's a very big project with a TRL with a high level of technical a high TRL level. It's a 11 million euro grant and a total amount of 12.8 million total costs. And these are the main objective of this project. So the creation of a tool able to quantify the impact of flexibility services on grid planning, and also to optimize the placement of the electric vehicle charging facilities to facilitate the operation of the grid. So by a correct planning, also having a way to relieve in some way the operation of power systems, to quantify the flexibility that EV fleets can provide. So we are not only focusing on private EVs, but also on EV fleets, on public transportation, so the vehicles used by public transportation companies, and also on heavy-duty vehicles and vessels. And this is the reason why we have also the municipality of Funchal in Madeira for allowing us to experiment this approach, also including vessels. And to facilitate the activation of EV flexibility services, so by creating dedicated platforms for contracting and pre-qualification procedures. So basically what we are willing to do is to demonstrate that EVs can provide flexibility, and that amount of flexibility can be used in the planning phase of the power system. And in addition to this, we would like also to improve the efficiency of the charging and the cybersecurity of the charging infrastructure. The core of the project is made up of the 7 demo sites that we will have. We will have 2 locations in Denmark, one at the university campus and one in the countryside. We will have 2 locations, one in Italy and one in Thren in Slovenia, at a bus parking lot. And we will have also 2 locations in Portugal, 2 in Funchal, one in the residential block and one downtown, and they are including also vessels in this. And the second location will be in Lisbon at the EDP parking lot. So I think my time has come. You can also follow the advancement of the project using this website, which is the website of the project. And so thank you for the invitation. I hope that in the coming years we will be able to give this presentation again, showing you the results we achieved on the inclusion of flexibility within the planning phase of distribution grids, flexibility coming from electric vehicles. Thank you so much.
Thank you, Samuele. This definitely highlights the importance of grid planning with the flexibility to accommodate this massification of EVs, because in the end, we need to charge them. So this sets the perfect stage for our next speaker. Our next speaker is Thren. He holds a degree in automotive engineering from Karlsruhe and has extensive experience in automotive electronic and electrical systems. He previously worked as a project engineer in powertrain and electronics at Magna Steyr in Austria, mainly focusing on ECU-specific hardware and software development. Currently, he is a project manager at Easelink, and he's here to present the progress in automated charging systems. Christian, please take it away.
Thank you for the introduction, Samuele. Thank you very much, and thank you for having me here. Let me just quickly open the presentation. And now, hopefully, you should be able to see it. Yes, as Samuele already mentioned, my name is Thren. I'm a project manager, and I support projects such as the HEAD project, where we also take part. Today, I will present the matrix charging solution by Easelink, which is a fully automated conductive charging system. So I brought for you today 2 points. So the first point is why automated charging in general, and the second one is matrix charging in the eTaxi project. In the following, I would like to provide 4 reasons for the need of automated charging in general. Starting with the first and the most important one. So hands-free charging is a key enabling technology for a sustainable, smart energy grid. A sustainable future requires the production of electricity from renewable resources, mainly solar and wind. But we cannot control when the sun is shining and when the wind is blowing. So we need a flexible grid to be able to always match electricity supply and demand. EVs have huge batteries, which can provide the necessary flexibility. A battery with 80 kilowatt hours can store energy to power a household for more than a week. So why not also use it than to just drive small ways? So next slide. No. Yeah, so maximizing the connections time is a key requirement for all smart energy grid applications. And within the HEAD project, which Samuele just presented to you, Easelink will develop and provide a system which is capable of bidirectional AC charging. Coming to the second point, the urban EV rollout. Hands-free charging for urban EV rollouts is really necessary because when you take a look at the picture, this could be taken anywhere in any European city. We can see already the impact of a very invasive charging infrastructure. Like shown in the picture, there's many charging poles and cables hanging and laying around everywhere. And this is clearly not how we want our cities to look like. So we need a simple solution to integrate the charging infrastructure seamlessly. Going to another interesting topic, which is the autonomous driving. And also there, hands-free charging is a requirement for the advance of autonomous driving functionalities. Although there are still some hurdles in the way, companies are making great progress. In the picture, there's a Mercedes-Benz EQS, which is equipped with a SEA level for number 4 for autonomous driving. If you're in Stuttgart and own a car like this, you can just go into the specific parking spot and your car will park automatically and autonomously. So there it's clear that nobody will run after his car to just plug in the vehicle. So also there, we need a hands-free charging solution. Coming to the fourth point, hands-free charging takes away the need for the driver to worry about charging, making the car more convenient for users. The evolution of cars is a nice example for automation. Electric windows, electric trunk, navigation system, voice controls, all these informations have the same intention: put the driver in the center and relieve them from simple tasks. In the digital age, this trend will surely continue. And charging is actually one of the main topics that people don't really like about electric vehicles today. Hands-free charging is a key element for a truly user-centric electric car. So summed up, you can see again the need for automatic charging. Coming to our system from Easelink, which is called the matrix charging system, and it consists of two main components. The matrix charging connector, which is mounted inside the vehicle's underbody, and the matrix charging pad, which is connected to the energy grid. To meet this suitable charging position, the matrix charging system uses UVB sensors to guide the driver to a correct position. Once the matrix is reached, the system can automatically connect to any position of the matrix charging pad, as you can see here below. Compared to other technologies, matrix charging does not need any living object detections, as only the pins underneath the rubber bellow, which you can see here, are electrically conductive. Coming to the second part of the presentation, the matrix charging in the e-taxi project. So first of all, the question, why taxi? The taxi use case is a quite difficult one. The charging system has to be robust against environmental influences such as rain, ice, or dust. It has to work reliably to not lose any money throughout the process for a taxi driver to provide his services. We choose this difficult validation case to showcase the robustness of our matrix charging system in the real environment. So before, charging e-taxi was always a loss of opportunities to drive customers, and therefore always a loss of money for each minute the taxi driver has to wait. Now with our system, taxi drivers can charge while waiting. It is a convenient approach for handling the taxi queue without having to unplug and move one place ahead, then do the same procedure of getting out of the car and plug the vehicle out and in again. Another really important point is that it is a great lever to reduce CO2 in cities. Many cities implement legal measures to reduce CO2 emissions, including the city of Vienna, where beginning from starting 2025, taxis are only allowed to be fully electrical. Here you can see where the e-taxi project takes place. We have two major cities in Austria, which is Vienna and Graz. We have multiple partners. To show a few of them, we have the cities of Vienna and the city of Graz, and also the energy contributors also in Vienna and in Graz, as well as the company car brands of Volkswagen and Hyundai. Within the projects, currently we have 35 electric taxis retrofitted, and we have 44 charge points in place. And the project is already running more than 12 months, making it the worldwide largest automated charging project. So let's take a look at the charge site in the Vorgartenstraße, which was actually the first charge site we implemented. The construction pictures are showing the seamless integration of the matrix charging in a public area. The e-taxi project is supported by two vehicle types. First, you can see here in front is the ID.4 from Volkswagen. And secondly, we also have the Hyundai Ioniq 5, which you can see here over in the back. Coming to the results, to the KPIs of the e-taxi project. In total, around 5.5 megawatt hours got charged into various e-taxis, resulting in an EV range of approximately 36,000 kilometers. And we made roughly around 3,500 charging cycles, making the e-taxi project a great success and paved the way for automated charging as well as a smart grid integration. To end the presentation, I also want to give you some insight how the system works. So I brought you a video where you can see the rubber bellow lowering down, blowing away any dust or pollution from the pad, as well as water. Then it finds the correct position from the pins. And once the position is correctly met, the vehicle begins to charge. As well as you can see, it's indicated with these blue lights over here. Then on the other hand, if you then have to leave from the spot or in the taxi project, move one place further by just simply pressing a button, the system will retract, the rubber bellow will go under the vehicle underneath, and you're ready to go. As well as seeing here from the down, you can see it's a dry surface and the charging was completed. I'm happy to answer your questions later on, and thanks for listening to my presentation.
Thank you very much, Christian. And actually, I found this solution very interesting at a personal level because I think it's really elegant to implement in an EV, and the application of automated charging and more user-friendly infrastructure not only applies to light-duty EVs, as well it is very important on large-scale electrification projects. So, which leads me to our final speaker, Alexandre Santos. Alexandre is a member of the board of directors at Transtejo Soflusa, which provides public river transport for both passengers and vehicles in the Tagus River. And he has a diverse background in energy efficiency, renewable energy, and management, including his time as a member of the board of directors at X. Alexandre will share with us the new electrical fleet of ferries at Transtejo Soflusa, demonstrating how important electrification is in public transports and maritime mobility. Alexandre, once again, thank you, and the stage is yours.
Thank you, Samuel. Let me welcome you all. As you already said, I'm a member of a public company. Let me just share my presentation with you. Okay, so here in Transtejo Soflusa, we took this new challenge of electrification, the ferries, part of our ferries, starting with a fleet of 10 ferries. Just to make to give you a framework of what we do. We are responsible for the public fluvial transport of the river in the region of Lisbon. And we have 5 connections through the river, which connecting Lisbon to the other shore, the south bank of the Tagus River, which is Almada, Seixal, Barreiro, Montijo, and Trafaria, Porto Brandão. That we have, and completing that, we have on our terminals, we have the connection to bus, train, metro, cycle tracks, parking for bicycle work. So we are responsible for 19 million transportation in over the year. and our goal was to start in the electrical way 3 of our 5 connections, which is responsible for 9 million passengers per year, divided in 6 million in 1 million per each one of the other, approximately. So our main goal was to improve, how can we improve the life of this region of Lisbon with approximately 3 million inhabitants. And we want to do that in the efficient energy way, and reduction the footprint, the environment footprint. So one of our main goals, besides give comfort and safety to the people, to our passengers, to reduce our maintenance cost, because we are talking about our fleet, our diesel fleet has a lot of costs because of age. But also, as I said, we want to gain some energy efficiency and to reduce our carbon footprint. So that was the idea, bringing to the Tagus River 10 of these boats, electric, totally 100% electric boats, from our fleet of 25. And as I said, to start for the connection of 3 of our connections. So with that goal, we want to add some value and innovation to our fleet, to our company, in the way that we could reduce the emission, because, as I said, we had some diesel vessels with a consumption of 5 million liters of diesel each year, and with retiring, and we want to reduce the CH emissions. Also, we hopefully want to give some efficiency technological with these new vessels, and hopefully operational and administrative advantage. So also, I usually say that this innovation, we also give a new passenger experience, because these new vessels, they don't have any noise, any vibration, any others. It's like the passenger experience during the crossover. It's a really new experience and new way to use the public transportation in the Tagus River. So that we came to our vessel. We bought 10 vessels for these 3 connections, and this, just to show you overall view of the vessel. This is 40 meters overall length and 12 meters height, and with the capacity of 540 passengers, and also very important, 20 bicycles, because we also saw that as a thing that will be matter for the passengers. So for these vessels, we chose a battery system based on electric motors could have the capacity to load in the terminals, and I'll show you further on. So these vessels have independent batteries models with a capacity of 906 kilowatts each battery, which allows a capacity of almost 1 hour and a little in the continuous operation during the work, during the crossovers. But for that, as I said, we need some charging stations. So as part of the project, which is the vessels and the batteries, we had to implement these charging stations that you can see in the picture. It's it's a very powerful charging station that can charge the vessel in 7 to 9 minutes to 19%. Just to give you overall of the project, because we are a public company, the overall project investment was almost 100 millions, approximately 96 millions, which represents almost 10 millions a ship, with all the towers and all the infrastructure. With that, we also believe that the new cycle begins in the Tagus River regarding the ecosystem and biodiversity. And we also chose the names of the ship were chosen by the birds in our Tagus River in order to become part of the biodiversity. So I have a small video, but I prefer to. I would like to share with you. So I'm glad to answer all the questions because it is an innovation project and we are starting, and later on I'll be glad to answer all of your questions. Thank you.
Thank you, Alexandre. And actually, this presentation I was personally thrilled about because I use the ferry every day to go to work. So I'm really glad to see some innovation on the public transport side, mostly on the vessels. So once again, thank you to all speakers for these insightful presentations, and we'll now open the floor for questions from the audience. And let me just share our 1 minute. Share these. Okay, so the first question from João Mateus is for Christian from Easelink. What kind of maintenance and support services are required for the matrix charging pad, and what is the expected lifespan of the equipment?
Yes, thank you for the question. So for this question, we have to differentiate between two possibilities. So on the one hand, you can see the e-taxi project, and the system has been developed for the life cycle of the project, which is 1 year. But on the other hand, we also work together with OEMs, where we are doing discussions for series integration. And there we can fulfill the series requirement from the OEMs. We are already doing some testing. For example, there was a test where they required 15,000 cycles, and we overdid this test by a mile and just stopped because there was no sense in going on with it. And within the maintenance, as you saw in the video, the system can clean itself. But if there would be like some damages, then this would be changed within the normal workshop.
Okay, great, Christian. It is also always important to know like some fatigue tests, some life cycle cost analysis. So this is always important to check on new products. Okay, so next question it comes from Francisco to Alexandre Santos. Does future project stages consider battery energy storage system coupled with the ship charging stations in order to mitigate contracted power costs? I don't know if you are aware, Alexandre, but what Francisco is trying to say is if on a charging station, if it has a battery accumulated to charge the vessel. Oh, you are muted, Alexandre.
Sorry, I couldn't hear you. Can you repeat some more? Sorry.
So, if Francisco Branco, one question. So, does future project stages consider battery energy storage system coupled with the ship charging stations in order to mitigate contracted power costs? So it's like having a battery allocated to the charging station in order to have a lower contracted power.
No, we don't have a battery system in the charging station. It's coming right from the grid, and the output is just to put directly to the batteries of the ship, with no power batteries in the station. But also we have the charging, the charging in the way not the speedway, the low way, and it's that way. It's again, it's coming directly from the grid. I don't know if.
Yeah. By any chance, do you know what is the charging power of those charging stations?
No, because we are just testing. That's one of the main issues of this project, is that we are just starting, and my presentation was about the project, but not the operation, because we are starting now the project, and a lot of things we are just testing, and this is one of the costs of being a pioneer, innovating. I don't really know the power, but it's the only thing. It's that we have this charging station, and we have all the like in our cars at home. We can use the speedway charging, and in our home we can do the other type of charging.
Okay, so we'll use fast charging during operation during the day, and we'll use slow charging during the night.
Yes.
To charge the vessels. Okay, great. So now I have a question for Samuele, and it's a big question. It's come from Umberto, and it states, do you already have any insights on how to predict the EV load?
Oh, well, thanks for the question. It's we are going to use a lot of data coming from the partners involved in the project. So we are going to use the load profiles coming from the public transportation company in order to assess a common profile for buses, for example, and for opportunity charging. So buses at the depots, but also for opportunity charging and for fleets. And I think that we are going to forecast the EV load by making use of artificial intelligence-based models, such as neural networks, in particular, long short-term neural networks, long short-term memory neural networks. This is what I can see as a foreseeable path for the forecasting of EV requests. I hope I answered this question. But you're right, it's a good topic, that one.
Yeah, we're also pursuing these EV load predictions in different avenues, in different projects, and it's always a challenge to accurately predict these EV loads and therefore the EV flexibility. Okay, so we have another question, this time from João Carvinho, and this time to Christian. So the benefits of your metric solution is clear. I would like to ask, what is the added cost of this kind of systems, considering all aspects, retrofitting, on-site, road installation, and so on?
Thank you for the question. So our business goal is to integrate the system into a series, and therefore to give you like a cost. It should be for the end user roughly about 3,000 euros. And then the system is already integrated into the vehicle, and the pad is already given within with the car, and then you have to install it at your garage at home, and that would be the overall cost.
Okay, and that is for an 11 kilowatt charger, right?
Yes, that's the 11 kilowatt AC charging. We also do development efforts for DC charging. This will later on then come as well, which has then the same look from the matrix. So there should be later on a capability of using AC as well as DC with the same matrix.
Yeah, I would say that it's a high-end solution, but a very competitive solution from what is in the market.
Yes, yes, yes.
Okay, great. So our next question comes from João Felipe Mateus, and is a question to Alexandre Santos. So, what safety measures and emergency protocols are in place for the electric ferries, and how do they differ from conventional ferries?
I have to say that the safety measures and the emergency protocols are equally, because we have the maritime protocols we have to follow. So the only thing that this vessel diverts from the conventional diesel is only the battery source. Instead of being diesel, it's electrical. But all the other things, the vessel will have to obey the protocols and all the normal protocols of the maritime authorities. So it just doesn't divert anything from the conventional ferry in terms of emergency protocols.
Okay, thank you, Alexandre. Sometimes on electrical vehicles, fire is a common hazard that everyone is talking about, but I think in ferries, that could be not that much of a big deal.
No, I mean, I understand what the question, but I have no requirement for that. Only to say that in the battery house we have a lot of measures, including AC, the temperature level, and a lot of conditions. But it's not obliged. I didn't have to do because of the protocols. I had to do because it's the consortium's rules. But that being said, it's about the temperature of the batteries, our concern, and it's in the closed environment. Okay.
Thank you, Alexandre. So one more question from João Carvinho to Samuele. What is the target audience for the AI-based tool for EV charging stations network deployment and planning? With increasing stations in the network and competition between different players, what is the role of legislators to ensure that the infrastructures follow the best model?
Well, this is a very big question.
Yeah.
Well, the target audience for the AI tool. So let's keep it simple, if at the beginning, and then I'll try to elaborate more on this. The target audience for the AI tool is mainly the distribution system operator, and with the participation of the charging procurement, the CPO, the charging operators, and they should play a role in the planning of this of the distribution grid. And the second part was about the regulation and how to ensure, if I'm not wrong, how to ensure the correct operation or the optimization. Can you repeat it, please?
Yeah, so the question was, give me a minute. And with the increasing stations in the network and competition between different players, what is the role of legislators to ensure that the infrastructures follow the best model?
Yes, now I can see it. Sorry, I was looking at the Q&A and not in the chat, so now I can read it. Thank you. Well, the legislators have always a major role in this, at this stage, because they are, let's say, drafting, they are leading the path for this deployment. And then in the future, they have to ensure that the infrastructure are designed and operated at their maximum, at their best. And the role is of paramount importance. So I would say that the legislators should be not only the watchdogs in the sense that they test and they check whether the grid is maintained and operated in the optimal way, but I would say that their role is also to steer the advancement of the grid in a sense that they should also induce the stakeholders and the players in the context in this environment to apply new paradigms, new tools, and to achieve the best, always setting the bar higher and higher in this process. I hope I answered this question, which was quite large.
It was a challenging question, and it's a big task to orchestrate the legislators, the DSO, the CPO, MSPs. There is a lot of players, so it's a really big challenge to orchestrate all of these players into a common goal. Okay, so I have here one more question to Christian, and it's just out of curiosity. What is the feedback that you have received from users regarding the practicality and user friendliness of these charging systems, or the matrix charging pad?
So now, yeah, for a couple of years we're improving. So maybe now the biggest improvement was that we changed for the retrofit case, which was also the taxi case. We changed to a display which is in the vehicle, and on the display you can see really good how to position on the pad and how to start and end the process. So there the feedback from the taxi drivers is that they can work quite good with it, and they have like a great response with this display. And overall, yeah, as I mentioned, the taxi use case is quite a difficult one, because also maybe not all the taxi drivers want the electric change. So that was also like quite challenging. but we could convince many of those taxi drivers with our system that it's just like more convenient. We just had to bring the thinking for them that they can charge while waiting in the taxi line, because otherwise they always had in mind, I have to go somewhere to charge on the fast charger, and this time I will lose a lot of money from it. And by implementing this taxi project, this was like a huge benefit to them.
Okay, so that's very interesting. So with the system, they can avoid losing money because they don't need to get out of the line in order to charge.
As well as many said that if the taxi is just plugged in, many people will not even approach the taxi because they see, the taxi is charging, I cannot go there. And if they don't see that it's charging because it's just underneath the vehicle, he can just press a button, and in the meantime, while he just sets the seatbelt, the system is retracted and you are already free to go.
Yeah, that's very interesting. I never thought about it. But yeah, thank you, Christian. So here a question from Humberto Queiroz to Alexandre. Did you consider installing PV panels, photovoltaic panels, on the roof of the vessels?
Sorry, sound was not connected. We did not, because in the project of these vessels, the power source comes entirely from the batteries. We thought that in our terminals, in order to use the slow source of charging. But that we had a challenge because since we don't have batteries, because it will increase too much the price the project. The PVs will be during the day, and I will do the slow charge during the night. So at this moment, I don't have any provision of installing PV panels either on the vessels or on the terminals.
Yeah, maybe we can run a research study to see how feasible it is to install PV panels on the vessels.
Yeah.
Thank you, Alexandre.
Yeah.
And I think we have a final question probably to Samuele. And again, since it is related to grid planning, it would be a big question. So, Samuele, in your opinion, what do you foresee as the biggest challenges in integrating EVs into the existing grid infrastructure? Do you think it's societal, technical, stakeholder engagement? What do you think?
Well, thank you for the question. This is well, I would say that it's it is a matter of all the three aspects you mentioned. So for sure it is technical, because having a huge amount of EVs will call for the need of a massive deployment of chargers, and also for what concerns the chargers, but also for what concerns the grid, which means that it will be it will need to be able to accommodate the requests of this, the energy requests of these vehicles. Societal, because in some cases we will be asked to modify our habits, maybe as a potentially, and also stakeholders, because there will be new players in this market. I mean the market of mobility, and I think that they will have to change the way they are approaching mobility for customers, and tailor this their understanding and their business model to the application of electric vehicles. So I think that these are the main challenges, and we are all involved in this. We are all involved in this.
Thank you, Samuele. That was a great answer. And I think we ran out of time right on schedule. But I'll like to ask the speakers. I think they are not, but if there is any non-answered question in the chat, please to reply offline. And once again, thank you all for your participation today. And I'll get back to Ines.
Thank you so much, Samuel, and thank you so much to our guest speakers for this amazing event. We have just reached out the end of this session. Thank you very much for your active participation. And the R&D sessions will be back in 2 months, always powered by DPNU. Enjoy your day and see you in the next one event. Thank you.